Existence and uniqueness of square and cube roots. Students know that positive square roots and cube roots exist for all numbers, and both the square root of a number and a cube root of a number are unique. Students solve simple equations that require them to find the square root or cube root of a number. So we're going to take a look at some rules, see if we can determine them. So if I want to go from 1 and still get 1, that could be anything. But 3 times what gets me 9? That's going to be 3 squared to get me 9. So then 2 squared is 4. So then I got to find the square root of 81, which is 9. 15 squared is going to be 225. Then we'll have to do the square root of 49 to get 7. 10 squared is 100. 12 squared is 144. The square root of 169 is 13. And then m squared is going to be m squared. And then if I need to go backwards, the square root of n is going to be the square root of n. So this rule is a number squared. So here on the other side, how do I go from 3 to 27? 3 times 3 is 9, times 3 more is 27. So you're doing times 3 times 3, so that's going to be 3 cubed. So 2 cubed is going to be 8. So remember, cube is you're multiplying that number by itself 3 times. So that means now the cube root of 125 is 5. Remember, cube root has the little 3 there, square root doesn't. 6 cubed is 216. 11 cubed is 1,331. Now the cube root of 64 is 4. 10 cubed is 1,000. 7 cubed is 343. The cube root of 2744 is 14. So that means if I want to cube the letter P, it's going to look just like that, P cubed. And if I need to go backwards, I'm going to cube root Q. That's a 3. It's really hard to write a 3 on here. There you go. So then this is the cube root of Q. So this rule, I didn't mean to make that big old line. This rule here is the cube of a number. Okay, so x cubed. For the positive value x that makes each equation true, check your solution. So x squared equals 169. Explain your first step to solving this equation. The first step is to take the square root of each side of the equation. So what I do is I write the equation, then I'm going to take the square root of each side just like that, and x equals 13. And the way to check it, I'm going to rewrite the equation, plug my 13 in for x squared, and you always put parentheses. So 169 equals 169, so it checks. Next, the square-shaped park has an area of 324 feet. What are the dimensions of the park? Write and solve the equation. So we know the area is length times width, but we know that the area of a square-shaped park is going to be special because all of the sides are equal to each other. And those little lines show that they're equal. So I can have area equals s squared. So area is 324, so I plug that in, is equal to s squared. I'm going to need to take the square root of each side. So 18 equals s, so the side lengths are 18. So this 18, 18. Now we're going to do the same thing with 625 equals x squared. I need to square root each side, so they get x equals 25. A cube has a volume of 27 inches cubed. What is the measure of one of its sides? Okay, so again, we're talking about a cube, so that means all these sides are equal. They all have the same measurement. So we start out with length times width times height. That's the volume formula. But seeing that we're talking about a cube and everything's equal, its volume equals s cubed, or s to the third. So now I need to take the cube root of each side. And you have to put the little 3 there or it's not the same. So then, oops, I put it on the wrong one. So take the cube root here. So s equals 3. So the side length is 3. So this is 3, 3, 3, 3, 3. What positive value for x makes the following equation true? X squared equals 64. So x squared equals 64. I'm going to take the square root of each side. So now x equals 8. What positive value makes the following true? X cubed equals 64. So now I'm going to take the cube root of each side. Remember that little 3 needs to go up there. So x equals 4. We'll get into this one later, but it's kind of fun to do. All this part here means that it's 1 over 256. So x squared of 1 over 256, find the value of x that makes it true. Okay, so I need to take the square root of both sides. So the square root of 256 to the negative first is 1 over 256. And the square root of 256, because what you really get here is you wind up with the square root of 1 over the square root of 256. So the square root of 1 is 1, the square root of 256 is 16, and then you just flip it back over. So now we need to find the cube root of 1 over 343. So you have the cube root of 1 over 343, which means you're going to have the cube root of 1 over the cube root of 343. So that's how you get 1 over 7, which then can go back to x equals 7 to the negative first. The next one wants to know if 6 is a solution to this equation. So I plug in 6. And every time you plug in a number, you need to put in parentheses around it. It does matter, because negative 6 squared is not the same thing as negative 6 like that squared. So we have to be careful. So I plug in 6 to each, so 36 minus 4 equals 30. 32 does not equal 30. So no, 6 is not a solution to that equation.